Hello everyone. The objective of this video is to give you a demonstration how to solve a hackathon. For this, it was shared to you all of you by the Learnbay team, and the objective over here is that the objective have been highlighted here. The classification goal is to predict if all the client will subscribe yes or no to a term deposit, that is the variable y. What the dataset tells you? You can pause for a second and read about all the details. The marketing introduction, the process by which companies create values for customers and build strong customer relationship in order to capture values from customers in return. That is a definition given by Kotler and Armstrong in 2010. Marketing campaigns are characterized by focusing on the customer needs and their overall satisfaction. Nevertheless, there are different variables that determine whether a marketing campaign will be successful or not. There are certain variables that we need to take into consideration when making a marketing campaign. The 4 P's of the marketing campaign is that segment of the population. First P. To which segment of population is the marketing campaign going to address and why? This aspect of the marketing campaign is extremely important since it will tell to which part of population should most likely receive the message of the marketing campaign. Second, the distribution channel to reach out the customer's place. So place is the second P. What does it say? Implementing the most effective strategy in order to get the most of this marketing campaign. What segment of the population should be addressed? Which instrument should we use to get our message out? Example, telephones, radio, TV, social media, etc. Third is price. What is the best price to offer potential clients? In case of the bank's marketing campaign, this is not necessary since the main interest for the bank is for the potential clients to open deposit accounts in order to make the operating activities to the bank to keep running. Finally, the fourth one, promotional strategy. This is the way the strategy is going to be implemented and how are the potential clients going to be addressed. This should be the last part of the marketing campaign analysis since there has to be an in-depth analysis of previous campaigns if possible in order to learn from previous mistakes and then determine how to make marketing campaigns much more effective. What is a term deposit? A term deposit is a deposit that a bank or a financial institution offers with a fixed rate, offer better than opening deposit account in which your money will be returned back at a specific maturity time. For more information on term deposit, you can go to this specific link. In this hackathon, you are being given two data sets, that is test and train. You have to train the model on the training set and then test it on the testing set. What is the solution you get, you have to submit a submission file with your name. Attribute information. The input variables for that attribute, that is we are highlighting from the train CSV format. Age, job, marital, education, default, balance, housing, loan, contact, day, month, duration, campaign, P days, P previous, P outcome, and Y. Y is your term deposit. Whether a person will open a term deposit as yes or no. The meaning of all of them have been highlighted over here. What is the blank client details? Age, job, everything is written over here. You can please pause for this screen and read about all the details that is necessary. The output variable over here is the 21st column, that is Y column. This is only present in the training set, not in the testing set. In the training set, we are using either binary yes or no. How we are going to evaluate it? We are going to evaluate it on the basis, we are going to evaluate on the basis of accuracy score. So you have to define whether you are going to use a regression model or classification model. On the basis of that, there is some accuracy score. What is the submission format? You have to submit. You have to, if the participant name is Shan Sharma, you have to respectively save in their person's name, Jupyter file, and CSV format. Let us dive into the project. First thing is implement relevant libraries. Guys, the objective of this video is to demonstrate the working of ML model and what is the approach to solve the real data problems. Please consider this solution as reference to solve the bank project hackathon. The relevant libraries that I need is import pandas as pd, numpy as np, import matplotlib.pyplot as plt, import cborn as sns, and I would be following this hackathon using one of the models, that is support vector. So I'm going to use my import from, so let's comment it. I will tell you later on which type of support vector we need out of that. So run it. The data set, that is a training set I have over here, train set is equal to, or just say it as df is equal to pd dot read underscore csv. My file name is train dot csv. Look at the top records of the data set. So these are top records of the data set which you're going to analyze further. We're going to analyze a few things and then we will go deep into the model. First thing, what is the shape of the data set? 3176 records, that is the training records I have, and 17 columns is there. Next is check for null values. So df dot is na dot sum. We don't have any na values over here, so good to go. Check for the columns. We can see that columns are also not having any spaces, so it is good to go over here also. Next thing we are going to study about what are the categoricals and numerical columns I have. So have a brief about it by using df.info, and we can see here a total of 7 number columns are there and 10 categorical columns are there. Since there is no na values, so there is no need for filling the na values. You are saving the time over here. I would like to analyze further the categoricals and numerical columns. If you're going to analyze categorical columns, it's good to go with the count type chart, count type plot, to see what is the distribution we have. So it might be possible that we have let's say marital, so it can be married, single, anything, or job, unemployed, services, private job, like that, default, yes, no. So such types of columns you're going to have over here. I like to see for categorical columns what is the unique value distribution over there. What is the unique value distribution for categorical columns? For this, what we can do, we can make a function or we can make a program, let's say categorical calls and numerical calls. What I'm thinking is that for the 10 categorical columns, except the last one, that is the output, I will take this output separately. So for output, it would be something like this: sns dot count plot df of y. We like to see it separately. So wow, there are a huge number of no cases as compared to yes cases. So what if we need here? We can't directly send it. What we need here is sampling. So what type of sampling? Is it down sampling, up sampling? That we'll discuss later on. Now category calls and numerical calls. Categorical calls to study the 9 categorical columns, and numerical columns I have 7. I can skip one of them and I can take it in a separate loop. So let's see if my for each in df dot columns, if df of each dot d type is equal to np dot object, we are going to fill the category columns, else it will be a numerical column. It will work in this case because I have only two types of columns. One is numerical, the other is categorical. If it is date time, we have to extend it. And you can see we have separated categorical and numerical columns successfully. Now making a chart for categorical columns, I am saying don't use the last one because it is a output. That is why is the output type. So I'm just popping it out. Why I don't want. And for the rest of them, I'm going to make a loop to give my 9 plots on the screen, because total 9 I have over here. Total 10 is there. I have removed one. So if you check for the length of categorical calls, that is 9. We are going to make a loop for it. So 9 subplots we are going to have. So fig x is equal to plt dot subplots, and I need to have 3 by 3. And what else I need? I need my share x so as false and my share y as true. So let's take it false only. And fig size. Fig size I like to leave 20 is to 15. For and counter is equal to 0. For cat column or for call in cat calls, value counts is equal to df of call dot value count. This is the value counts because I would be making a bar chart using a using your either you can go with either you can go with SNS or you can use a matplot.plt also. I'm going to use matplot.plt bar chart. For that bar chart, you need to have a group by type of data. So I'm going to group by each one of the column. Let us take one column at a time. So my df of one of the categorical column I think I have is marital dot value counts. So what I need, that these 3 values for this marital column, I need the names as well as I need the values. So the bar chart is going to work on the names and values. So when I say value counts, it is going, and what I'm sharing over here, value count, this is nothing but the data frame. A data frame I'm sharing over here. Okay. So just wait for 1 minute. Let me write the code. You'll get the idea. We have to do trace x counter or by 0 and trace y is equal to counter mod 3, and my x position is equal to np dot range 0 till length of the value counts. My x is trace x comma trace y. So what I've taken total 3 by 3, that is a total of 9 subplots I'm going to have. On these 9 subplots, when I will take 3, the very first value that I will get from this integer division is going to be 0, and very first value which I'm going to go over here, so a counter, that is 0 mod 3, remainder of that will be also 0. So first of that part, I'm going to plot the chart. So similarly, it is going to increase. So next thing is going to be, this is a floor division. So counter divided by 0. So counter divided by not 0, it's 3. Okay, floor division. So 0, then it will be 0, then it will be 0. And this is going to be 1 and then 2. That will be the very first 3 values. So on your x-axis, 1, 2, 3, I have 3 y values over here. 0, 1, 2. So 3 charts will be there in a single row. And similarly, it is going to be there 1, 1, 1, and then it will be again 0, 1, 2. Then it will be 2, 2, 2, and below it will be 0, 1, 2. So 0, 1, 2 highlights the column numbers, and 0, 0, 0, that the first row, second row, third row. This is what we are doing with the help of trace x and trace y. So very first plot which I'm going to use is over there bar chart x pose, that is total 3 values I have over here, and my value count is equal to, sorry, value counts dot values. So I can write here dot values, and you can see I'm getting only numbers over here. So this is what I'm getting, numbers. And what I need is a tick label. A tick label is equal to value counts dot index, print index. Now you can see the very first thing, print you can see this is the first information, value counts, that is sharing. Now from this value counts we are asking the values, that is these are the values, and then we are asking the index. So these are the indexes what we have. So we have got your covered with the x-axis also and the y values also. So we are going to get a bar chart over here, and the only next thing is remaining is that for this part of chart, oops, this part of chart dot set title. The title, should be equal to the same column name. So very first column is the job. I would like to have that as a job column name. So your call, that is a title. And finally, we are going to mention over here counter is equal to counter plus 1. Else this 0, 0, 0, 1, 1 I will not get. The counter will keep increasing of 0 to 9, and the numbers are going to change over here. Okay, this is the function you can write. And finally, plot dot show. Wait, and you can see here that we have got the plot for all of them. Now for job, it is hard to read over here. I think, yeah. So on x-axis it's hard to read for the very first column. Rest of them, the x column names I am able to read out. What you can do, there is a solution for that also. So for only x-axis you need to change the orientation. So you can say here for tick in axis, for tick in this axis, got get tick labels. text doc tick labels, we are going to do tick dot set rotation. That's it, 90. Yeah, run it. Axis plot. Such the mistake here is that I'm talking about X tick labels. Now you can see the labels have been increased, and figure size you can also increase over here. So amongst the job, we are getting highest number of records from e-collar types of jobs, and then some segment is there. Then technician, admin, services, and such names are over there. And minimum are we're getting from unknown sector. Marital, the maximum population is the merit class. Those who are having the bank accounts, they are the merit peoples. Over here, education. So maximum are just secondary, that is 10th class, and after that, primary are also there, and your ternary the 12th class and unknown. So default, how many people have defaulted it? So for no, you have such huge number of records available. Housing, so who has taken the housing loan? So once approximately 70-50 plus records are there. And loan, how many of them have taken a loan? So approximately 2500 plus people have taken a loan. And similarly, you can get more information on these sectors. Okay. Similarly to this, your categorical column, you also can do for the numerical column. So for numerical column, we have total of we have a total of 7 columns. I don't want to use 7 columns, so I can remove one of them. For 7 column, it will be hard to do. So what I'm doing over here my numerical calls dot remove age. So I removed the age. We will separately do it, and rest of them it's same. So total 6 are there. So I need 2 by 3. 2 rows, 3 columns is more than enough to get the information. And over here, it's not a bar. Now I want histogram. So your hist, in that you can write here, you are referring to df or call. Okay, and set column index. For taken tables, this. So I think there is no problem in that. Only thing is you have to change here. Instead of cat calls, you write it num calls. And I don't need value count also. And enter. So you can see here, 6 plots we have got. Starting from balance, people are keeping zero balance. Approximately 2000 people are there. Day wise, how many people are opening term deposit? What is the day they're coming up? So the majority of them comes between around 20 only, and by the end to save the money. Duration, people are looking forward in duration is I think in days. How many days you're looking forward, or how many? I think duration is duration here. Last contacted duration. Okay, in numeric seconds. Important note: this attribute highly affects the output target. Example: if duration is 0, then Y is no. That is, people don't open a term deposit. Yet the duration is not known before a call is performed. Also, after the end of the call, Y is obviously known. Thus, this is input variable should only be calculated for benchmark purpose and should be discarded if the intention is to have a realistic predictive model. and campaign, p-days, and previous. So these are the things you can also do, perform some analysis on that. Got it? And what I can do, I would like to change the name of my last column. So my last column is Y. I like to treat as a deposit. For that, what we can do, we can perform a df dot rename. I am renaming my column. Yeah, columns is equal to the previous name is my Y. I like to treat it as deposit and make the changes permanent. So in place equal to true. Df dot head. You can see the last name have been changed. We can further point out to other analysis also. So that I leave to you. It can be a lot of analysis you can perform over here. So as I said, we have on the diagram we can see over here the people who are opening, sorry, who are having a deposit, yes or no. For no, we have such a huge number of cases. Okay, so we have to do a lot of tasks for that, and what we can do over here. To solve the sampling problem, that is to work on the imbalanced data set, what we can do, you can actually go with either downsampling, that is you can decrease the majority cases to match the minority, or you can go with oversampling, that is increase the minority cases to match the majority. That you can do. You can take help from the SMART process also to solve it. Now there are three methods you can do before you can apply a ML model. These methods are the above two. Before using ML model. Now this SMART is like a ML model only. Okay, using ML model directly to work on the imbalanced data set. So you take help from the SMART process to get the training and training set. And this particularly can help you do the oversampling. It can help you with the oversampling of the data set of training and testing set. On the other hand, I'm going to teach you one more thing, that like other classifiers which we call it from the sklearn to solve the solution. Why I'm using classifier? Because my target variable is deposit that has two categories, yes or no. So categories can be only solved with the classifier things. If I'm using sklearn classifiers, that will make me a biased solution, as my majority cases are no. You can use the imbalanced data set also. Imbalanced learned classifier you can also use. That can help you with more accuracy. Let us compare one sklearn and one imbalanced learned classifier. So from sklearn dot svm import svc, that is a classifier from the sklearn. and I'm asking from my imbalance learn. Do we have an ensemble method over here? Import bagging. You can see here bagging random forest classifier or balanced bagging classifier. You can use any one of them. I'm using the simplest one first of all. Let us analyze over the SVC first, how it works. For SVC, before we can start working, we need two things. That is, we need a training set and testing set. Training and testing sets, we are going to take it from our, this is applying ML model. For training and testing, we use from sklearn dot model selection import train test split, and my X train, Y train, X test, Y test, I have to derive from my X and Y. For me, my X and Y are, my X is the entire data set except the deposit column, and Y is the deposit column itself. We are going to write over here, my X is df of dot drop deposit, and my Y column is df of deposit. After that, my test size, I like to keep it as test size is equal to 0.3. 30% I like to keep as testing size. And finally, this is a testing size, random state on which I will be making the calculation is equal to 45. Example purpose. So you have taken X train, Y train. What is the problem here? Deposit not found in the axis. Okay. What I have to give it a name? DF. Is it updated here? So DF is there, and we have deposit spelling mistake, I guess. So deposit. Acha, this is X is equal to 1. Done. So my X train dot head looks like this. Entire column except the deposit, and a Y train dot head is a Y train dot head. Acha, Y train will also be same, but X test, sorry. My testing set is only the last column. As we are working on the data set, I forgot to mention one thing, one important thing, that you have to clean the data. Before I can apply, I got diverted to my imbalanced data set. So before I can apply, you have to clean the data. For cleaning the data, guys, what you have to do, there are a couple of steps you have to follow. First step is like I have to convert columns yes and no to numerical columns. That I will be doing. Second thing, what I need, the categorical columns what I have all will be converted in numerical also. Numbers, and this will be zeros and ones. Third thing is that we do in the cleaning the data set is drop the irrelevant columns. And finally, the fourth step we are going to do impute incorrect values. These four things I'm going to make different function to solve it on my main df. So function you can take it as like, for example, def get dummy calls from boolean. So where yes and no is there, what you are going to return. That is the first function for me. Next function is impute the incorrect values. That is wherever I have let's say, let me show you, like, and then define cleaning set. Define clean data. This is the function for me. What I need to do over here, and what I need in this particular function, I need data frame. So first of all, I will take a copy of it. So df is equal to my cleaned data is equal to df dot copy. Now considering these charts, you see again my boolean values are here present in my default housing, my loan. These three columns are there: default, housing, loans, and deposit. That is the last column I have. Why? So my bool calls I have over here is default, loan, housing, deposit. These are the boolean columns I have, which I need to impute. So the function which I have written above, what is going to return? It is going to return 1 if any of the boolean value that is passed from here. Okay, what I need two values over here, row and call name. So these are the column names. What I will be doing, df of call underscore name is equal to yes. I'm going to return 1, else I'm going to return 0. These are the boolean values function I will create. So for boolean values, what we are going to do, for bool call in bool uh, columns, df clean df. Over here I will create a new column. I will take it as bool call, which I have taken, plus we are going to insert one more word for that, that is bool, to highlight that we have created after applying on these 4 columns boolean functions, what is the output column? It should be having something bool. So default, for example, so default bool will be created, that will be highlighting 0 or 1. Wherever it was yes, it will take it as 1, and for 0 it will take it as 0. So sorry, there no, it is going to take it as 0. And what we are going to do, we're going to apply the function over here. So df dot apply lambda row get dummy call, and over here I have row and column call, and finally x is as 1. This is the first thing I have taken care of, the boolean columns. Second thing is that what all categorical columns I have, I need to convert categoricals to numerical. So this next second thing I have written over here. First thing is taken care. Second point, we're going to take care over here. So my categorical columns, that all I have left over after that. So cat calls which are left over, I'm writing these things. So we have your job, marital. Next I have education. Next I have your contact. Next over here I have the month, and finally I have over here P outcome. These are all the categorical columns I have. We'll take one by one all the columns over here. So for call in cat columns, we are going to apply a clean df. We are going to ask that clean df to do the concatenate, and over here concatenate with the clean df and insert all the columns one by one. Okay, so my clean data frame which I will be getting over here is that from the clean data frame we're going to drop the same column over here. So call at x is equal to 1, because if the category to numerical conversion has been done for job or marital or education or contact or any one of them, so there is no need to keep that particular column again. So I'm doing in single line. After this, what I'm doing, I will be taking a dummy value. So pd dot get dummies values for the clean data frame. Over here I'm talking about the same column, and prefix we're going to keep as the call only, and my prefix separator we're going to keep it like underscore. After making the dummy values, I would like to drop the first value true, and what else I want, dummy na. I don't want na values after that, so dummy na is equal to false, and this thing I would like to execute. Is a column I am keeping over here, so it's been exaggerated. This is the column and x is equal to 1. So you've taken care of the second part, categorical to numerical. The third is dropping the irrelevant columns. So for me, the dropping the irrelevant columns is, it was also highlighted in the same readme point. There's a column called as over here p days. So number of days that passed by after the client was last contacted from the previous campaign. Numeric 999 means client was not previously contacted. You don't need to keep that thing under the model. So for me, the relevant column is clean df dot drop. Oh, sorry, is equal to clean df dot drop p days. That is the absolute unnecessary column for me. And finally, the fourth point which I have written over here, impute incorrect values. Over here I have irrelevant column over here. Now not, we are going to return our data frame, clean data frame. Syntax, so x is equal to 1. Done. My clean data frame is equal to, or my final data frame is equal to clean function, clean data. Over here df you will want to pass. What is the problem over here? The truth value is seriously ambiguous. So we are getting the problem in this function. Cat cost will be converted to number. So in this function, we are getting the problem. Done. Some mistakes were there, so we have corrected it, and now it is done. So clean final data frame we have got, and final data frame dot head looks like this. So we have all the number columns over here. Now for this final data set, what we have taken, we are going to do final df, and this is also final data frame. X train, Y train we have got, and now model is equal to support vector classifier over here, and we want the support vector classifier to take up the models, and model dot fit my X train and Y train, and after that the model, just one second, but I have not converted the deposit. We have converted a deposit, so my deposit is okay. So there was a small mistake over here. It has been corrected in this place, and after that we are able to get the default tool. Same thing, everything is same, but the small mistake was there, so it has been corrected. Please go through that. Now columns have been updated over here, and now to work on the imbalanced data set, we are going to split the data set into training and testing. Now first of all, we are going to try with deposit not found in access. So name have been updated to deposit tool, and over here also deposit tool. And now training and testing, for that again there is something. Y should be 1D array, got a shape of 95341 instead. Check the shape of all of them. So print my X train dot shape, and again Y train dot shape. So my X train is 22353, and Y train is however coming to be 953. X train, Y train, X test, Y test is train test spread. Final DF, what we have received, I have not updated here. Okay, this is the final DF over here. Clean data. Print final data dot shape. So we have 3176 and 42. 3176 records with 42 columns. And after that, we are taking 70% to the training and 30% to the testing. Okay, my mistake here is that X train, X test, and then Y train, Y test. Now it is of both of same size. This time it is going to work. And after this, we have taken a model of fitting. Finally, it comes out to be prediction. So my prediction, what we are trying to predict, we are trying to predict, first of all, we can take both of them, that over on the training set itself, how better it is working on the training set. So I can say Y train predict is equal to model dot predict on the basis of X train, and my Y test predict is equal to training on the X test. We are going to print both of them. So from sklearn dot metrics import accuracy score. train. My accuracy score for the training set is or training set is equal to accuracy score. Over here you have to pass out y train and y train predict. While for the testing set, it is y test predict. Y test is found input variables. So we are doing it accuracy score y train y test predict. Sorry. It is going to be y test and y test predict. So we can see it's a good, relative good accuracy score from the SVC, where we have not taken any imbalanced data set. Sorry, we have taken imbalanced data set over there. So at that time, the accuracy score coming out to be 0.87 and 0.88. Now we're going to apply our balanced bagging classifier. For that, it's a part of the ensemble model. So we have extracted that thing. Same thing what we have done above. We are going to create our, let's say it's BBC model is equal to balanced bagging classifier. Over here the base estimator, now there are various parameters over here. So base estimator that I'm going to pick up is the decision tree classifier. Okay, I've not imported it. So from sklearn dot tree import decision tree classifier, and over here is decision tree classifier. The next type of the next thing I have the sampling strategy. I would like to keep it as auto only. I don't want to manipulate it. Let the system decide what is the best practice and we can do it. Shall the records be replaced by some other records? So I don't want the replacement to be there. And finally, there is a random state over here also. So random state, you can pick up anything. I can take one over here. After BBC model is being taken, you would like to ask the BBC model to fit with the train and test. So X train and Y train. And finally, we will ask the BBC model to predict. So BBC model predict Y train. On Y train, how it is going to perform, and similarly on X train, how it is going to perform. Like we have a Y train and X Y test. So it's a BBC model dot predict on the Y train, and Y test, it is equal to Y test. Predict on X train and X test. Sorry. So X train, X test, and let's print it out. So accuracy score for all of them. For now training part, I'm going to copy and paste here, and for testing again copy and paste here. So relatively near about. So there was no need to go with the imbalanced also classifier here. It was relatively equivalent we are getting for the training, and training is 0.87 over here and 0.88, and for the accuracy score I'm getting is 0.82, and over there I'm going to 0.88. So you can keep any one of them. The next thing that comes up, get the testing set. So my testing set We're going to pick up the testing set and give it a name as you can take it testing only. So test set is equal to pd dot read underscore csv, and over here we have the name is test.csv. Now in this test.csv, everything is common except for the last column. Now you can see y is not there, that is deposit is not there. Rest everything is same. So what we can do, we can directly copy and paste the cleaning method over here. That is, we can apply here the same cleaning method, only with one change. The deposit should not be there now. The deposit should not be here. Rest everything is same. So I keep the same name, and my testing set, let's say it's test set, again same name I would like to keep. My clean data frame, clean data test set. So after cleaning it, I would like to save it in the same variable dot head, and now you can see everything is same as above. The only thing is I'm missing the training and testing. I don't want to do training and testing, and directly I would like to apply my testing. So I can ask my Y model. So I can say my final predictions or my fine, that is SVC prediction is equal to model, for which I was using SVC over there, dot predict directly on the X test test set. Similarly, you can ask your BBC prediction to be the BBC model over there. So answer have been given, and if you want to have a look at it, you can write down here SVC prediction. These are the arrays, and dot values. This is numpy sequence. So print we got the 0, the 1 from here also, and from there also I would like to go with SVC prediction dot. Yeah, we can do one thing, like I'm doing the prediction over here, so you can create a data frame. After that you can get that set. So my SVC prediction can also be equal to pd dot data frame. Over here the data that I am passing is SVC prediction, and my column is equal to prediction. Similarly, I can say for BBC prediction. Now I can show you the answer, that SVC prediction dot prediction dot value count. So over 0 we have 1, 3, 4, 5 as the records, and for BBC it's this distribution. So you can see now SVC is only and only favoring 0. So everything in the single column you're going to get 0. But for BBC you're going to get both of the records. So maybe better prediction with the help of BBC balance classifier. And I would like to have my balance classifier saved also. Dot to CSV file, and is the submission file, so I can write down your personal name. So write down your name, person name, submission dot CSV, and I don't want to keep the index over there, only the values. Done. Now if you go back to the directory, you will see your person name submission.csv, and if you open it, you can see a value of zeros and ones over there. This is what we need to evaluate your answer. So we are going to match it with our test cases, what we have. We are going to make different models, apply our test cases on your data set. The one who is getting the best accuracy score, that is going to be the winner. Again, it's a request that take this as a reference video. Don't take it as a final video that this is the only method. There can be n numbers of methods. Now it depends on you guys how you are approaching it. So this is all for the banking algorithm data set. Wish you all very happy learning and take care.